I'm Chris Thompson, and today Diego Lomolini and I are presenting version 2.0 of SharpSCCM. SharpSCCM was written to help pen testers and defenders demonstrate how Config Manager, Microsoft's enterprise application, software update, and operating system deployment solution, formerly known as SCCM, can be abused by attackers to conduct recon, credential gathering, privilege escalation, and lateral movement to further their objectives. On the agenda, we're going to talk about some useful resources for attacking and defending SCCM, some sharp SCCM commands that can help you, what a site takeover attack is, and the known attack primitives for site takeover, followed by a demo, and then a new command for accomplishing assessment objectives with sharp SCCM without moving laterally to SCCM clients. Here's a link to sharp SCCM's wiki where you can find usage and examples for the commands that it supports, defensive recommendations for admins, config manager admins, database admins, firewall admins, etc. Some links to our research and blogs about attacking and defending SCCM, and some resources for building your own lab so you can test this out yourself. Also, if you want to check out the videos that we've previously recorded, you can take a look at that YouTube link. Also, if you'd like to take a look at some of the other tools that are out there for attacking SCCM, highly suggest taking a look through these, which informed a lot of our tooling as well. Here are some useful sharp SCCM commands. The first three are for local recon and cred gathering when you're on an SCCM client. The site info command will identify that client's management point and the code for that site. Local secrets will dump passwords like the network access account, collection variables, and task sequences from that client's local WMI repository. And a local triage command will dump information like distribution points and software from the log files on that client. If you'd like to use sharp SCCM to interact with the SCCM servers and you have admin, you can use the exec command to execute a command or coerce authentication from a specific client. You can use the get devices or users commands to dump information about those devices or users. You can use the get primary users command to identify where a specified user is the primary user. This is really useful for lateral movement if you're trying to find where a user may be logged in so that you can compromise their session. You can use the get secrets command. This one does not require admin. This just requires a machine account and password. That will allow you to retrieve secret policies from a management point and decrypt things like network access accounts, collection variables, and task sequences. The three commands we're going to focus on today for our demos are the get site info command, which will identify the primary site server using a technique discovered by Garrett Foster. The invoke admin service command, which is written by Diego and uses CM pivot to gather information such as registry keys and values, file contents, and things like that from any client in real time. And the invoke client push command, which we talked about in some previous demos, that allows you to coerce authentication from the site server account, which is going to enable some of our site server takeover primitives. So what does it mean to take over an SCCM site? Essentially, it means obtaining the full administrator SCCM role, which will allow arbitrary command execution on all clients, access to very powerful features like CM pivot and run PowerShell scripts. And it also can allow an attacker to impact the availability of software by taking down distribution points and things like that. The key concept to all of the site takeover primitives that we're going to talk about is that the primary site server's domain computer account is required to be a local admin on the site database server, is typically a local admin on every other site system role for when that role was installed by the primary site server, and is used for client push installation by default after any admin-defined client push installation accounts fail to authenticate to an endpoint to install the client software. So that means if we can coerce authentication from the primary site server's domain computer account and relay that authentication to something like the site database, we gain full control of SCCM. Here's a reference to the site takeover attacks that we're currently aware of. In our opinion, These are listed in descending order of their likelihood and potential impact. By far, the one that we see the most often and the one that we hear about the most is Site Takeover 1, which is just dumping overprivileged account credentials that are stored on SCCM clients or available to SCCM clients. So that may be a network access account that's present in the local WMI repository on each client and can be requested from a management point in the machine policy, or operating system deployment, domain join credentials, or local admin accounts that can be pulled with tools like Pixie Thief abusing Pixie Boot. The second site takeover is the one that we're going to demo today, and that involves coercing SMB authentication from the primary site server and relaying that authentication to the SQL service on the site database. That'll give us access to the database command line, where we can grant ourselves the full administrator role and take over SCCM. The rest of these attacks, if you have any questions about them, we're not going to go over them in detail now, but please feel free to reach out. To do the Site Takeover 2 attack, we need to confirm that a few prereqs are in place. The first, the site database has to be on a separate server from the primary site server, because you can't relay credentials back to the system where they originated. The second, SMB needs to be permitted from the primary site server to our relay server. The third, we need to find a suitable relay target. In our demo, we're going to target the MS SQL service on our site database. And the site database needs to not have extended protection for authentication enabled, which is the default setting, so we should be okay. Fourth, we're going to coerce NTLM authentication over SMB. We need to decide between using RPC or automatic client push installation. They're useful for different reasons and different circumstances. Most of the time, RPC is going to be a better choice. There are fewer requirements, but it does require that SMB is reachable on the primary site server, and you can use something like Petit Patam or Spool Sample to coerce that NTLM authentication to your relay server. Automatic client push installation may be preferable if you only have access to HTTP on a management point and you can't reach the primary site server over SMB. It has a few more requirements, but if automatic client push installation is enabled for the site, it is possible to coerce authentication from that primary site server machine account and relay it to the site database to do this takeover. To do this attack, we need to first identify the site database server. So unfortunately, we don't know of any reliable methods of gathering this information from a client, but the best we've come up with is to get the spins for all of the MS SQL servers in an Active Directory environment, or worst case, scan for MS SQL servers in the network, and then compare their names to the names of management points and distribution points, which is information that you can get from a client. The next thing we need to do is locate the primary site server. The primary site server is going to have generic all permissions or full control of the system management container in Active Directory. So if we enumerate that ACL, we can positively identify the primary site server. We can do this with SharpSCCM's get site info command or SCCM Hunter's find command. Next thing we need is to get the SID for the user account that we're going to grant full administrator privileges to, and we can do that with the SharpSCCM local user SID command. On our relay server, we're going to configure NTLM relay X to listen for incoming SMB authentication, and when it receives SMB authentication, it's going to forward that to the MS SQL service on the site database and establish a SOCKS connection that we can reuse. Next, we're going to coerce NTLM authentication from the primary site server using the relay's listening IP address in our path. We can use Petit Patam or Spool Sample or Coercer if we want to coerce authentication via RPC, or we can use SharpSCCM's invoke client push command if we want to coerce authentication through a management point when automatic client push installation is enabled for the site. Next, we're going to receive the SMB authentication from the primary site server's machine account on our NTLM Relay X listener. That's going to establish a SOCKS proxy with the MS SQL service on the site database. And then we're going to configure proxy chains to forward traffic over that SOCKS proxy. And we're going to proxy IMPACKET's MS SQL client to the site database server over that proxy using the credentials of the primary site server's machine account. Next thing we're going to do is switch to the site database, which is named CM underscore and then that 3-character site code by default. And then we're going to add the hex version of the Active Directory SID and the full name for the user we want to give privileges to with the site code into the RBAC underscore admins table in the database. This is going to give us an admin ID that we can use for further operations. After adding that entry to the RBAC admins table, we'll get the admin ID for our account, and then we'll add 3 records to the RBAC extended permissions table to grant that account the full administrator role ID for all objects, all systems, and all users and user groups. All right, time to jump into the demo. Quick overview of the lab we'll be working in. We've got an SCCM client where we'll be executing SharpSCCM from. We have the management point that the client communicates with. That's where we'll send our requests to coerce automatic client push installation. The site server, where the machine account resides that we'll be coercing authentication from. The Kali box, where we're running NTLM Relay X to receive that authentication. And the site database, where we will be forwarding that authentication to in order to take over the site. The first command we're going to run is SharpSCCM's get site info command for our domain, which is going to tell us that the primary site server is named site server. Next command we're going to run is SharpSCCM local user SID command. That is going to give us the hex encoded version of the Active Directory SID for our current user that we're going to grant permission to. Next, on our relay server, we're going to run NTLM Relay X with SMB2 support. We're going to listen on the IP address of our relay server, and we're going to forward connections to the MS SQL service on our site database server's IP address, establishing a SOCKS proxy to that IP address. Next, we're going to run the SharpSCCM invoke client push command, targeting the IP address of our relay server. This is going to send a registration request to the management point for the client we're running SharpSCCM from. We're going to receive a GUID for the client we just registered, and we're going to send a follow-up hardware inventory saying that the client is not installed on the IP address. And that is going to result in client push installation if automatic client push installation is enabled for the site. You can see on our Kali machine that we received authentication from the site server, and that authentication was forwarded to the MS SQL service on our site database, where we authenticated as the machine account, and that authentication was successful. And now we have an active SOCKS connection to the MS SQL database that we're going to connect to. In a new window, we're going to double check our proxy chains configuration to confirm that it is targeting the SOCKS proxy on port 1080. And then we're going to run Impacket MS SQL client over that SOCKS proxy using proxy chains and the authentication for the site server machine account, targeting the MS SQL service at the IP address of our site database using Windows authentication. You'll be prompted for a password here, but you can just press enter and you'll be dropped into a SQL prompt. Next, we're going to execute the use CM underscore 3-character site code command. Ours is PS1 in this case. And we're going to change database context to the site database. Next command we're going to run is an insert command into the RBAC admins table. And we're going to put our hex user SID in there, as well as the domain short name and account name for the user we want to grant privileges to, and the 3-character site code. Next, we're going to snag the admin ID that we just created from that table. So we can see there was an entry created for our low priv user, and the admin ID is in there. Next, we're going to insert 3 more records into the RBAC extended permissions table using the new admin ID for our low priv account. We're going to insert a record granting the all objects permission. We're going to insert another record granting the all systems permission, and we're going to insert a third record granting the all users permission. Now, just to see the effects of this, if we go over to the site server, we can see that our low priv account now has the security role of full administrator. Now, if we come back over to our client where we're logged in as the low priv user, we can execute privileged sharp SCCM commands that require full administrator privileges like get devices. From here, we could also execute something like the sharp SCCM exec command to move laterally to any system that was a client that we wanted to. So how do we prevent these site takeover attacks? Basically, we need to prevent, or if we can't prevent, detect NTLM relay on the targets of that relayed authentication. So we can require SMB signing on the target in order to prevent relay to the SMB service. We can require LDAP signing or channel binding on domain controllers to prevent relay to LDAP for resource-based constrained delegation attacks or shadow credentials attacks. We can require extended protection for authentication on the site database servers, MS SQL service, to prevent the site database takeover that we demonstrated today. We can require EPA for ADCS servers to prevent relay to the HTTP service to enroll a certificate. And we can block unnecessary connections to servers hosting site system roles. So we might want to block anyone from connecting to the MS SQL service on the site database that doesn't require it. So we can probably restrict that down to the site systems in the hierarchy. To detect these attacks, if you're not able to enable all these mitigations or want to do something while you're enabling them, you can try and detect if the site server computer account is authenticating from an IP address that doesn't belong to a site server. That is definitely an indicator that those credentials could be relayed through another system. You can also detect whether or not client push installation accounts are authenticating from systems besides the site server. They should always be originating from the site server in most cases. So what can we do with these privileges now that we're a full administrator? Well, we can move laterally to other clients by executing a binary on them with SharpSCCM. We can also coerce authentication from the logged on user or the machine as system using the SharpSCCM exec command. There's a demo of that on the YouTube if you want to check it out. But the next demo we're going to do is running CM pivot, which is a function of SCCM that exposes a REST API that allows you to deploy an operation to a device or a collection of devices and collect the results. So this allows read access to multiple clients at once in near real time. You can read things like file contents, registry values, the members of the local administrators group. You could also collect session data through enumeration of event logs, 4624 events, in order to see who's logged into a system to see if you might want to move laterally there to dump their credentials. This was contributed to SharpSCCM by Diego, who is going to dive into the demo.
In this demo, I'm going to show you how we can leverage the admin service REST API to execute CM pivot queries by using SharpSCCM. Before that, let's look a little bit into the intended use of CM pivot. CM pivot, being a part of the configuration manager framework, will allow us to execute queries and enumerate different information against resources part of an SCCM site. Let's attempt to run a query against the GW1 host. Here within the CM pivot console, we can see on the left an excerpt of many queries that we can execute against SCCM clients. Let's go to the Query tab and attempt to execute a single query against the GW1 host. This query is going to attempt to enumerate all the installed software within that particular client. And once we receive our results, we can see the product name for that installed software, the product version, and some other details as well. These queries can also be filtered to better target our information. And these filters can be run against the information that we have retrieved previously, or they can be applied to a query that's made from scratch. These queries can also target different groups of resources or collections as they are known within SCCM or Configuration Manager. Let's attempt to run a query against the All Systems collection. This query is going to attempt to enumerate the operating system of any SCCM clients that are currently alive on the network. Here we can see on our results, we have retrieved the operating system for two different hosts, the GW1 and the MDT1 host. Again, we can use some filters to better target our information. And this is a basic demo of the intended functioning of CM Pivot. This CM Pivot queries can also be performed by leveraging the admin service REST API. Let's look at an example on how to do this. Here we're using PowerShell to send a post request to the admin service REST API. We're including our query as part of the body of the request. This is the same query that enumerates the operating system, and we're sending this as JSON. The request is being sent towards the management point of the SCCM side, and we're requesting for the admin service endpoint. Our query is going to be run against the collection SMS 00001. And if you recall, this collection points to all the SCCM clients that are currently running on the environment. Finally, the method admin service.runCMPivot is being requested. From these actions, we expect to receive an operation ID. So let's go ahead and run this. Once we have received an operation ID, let's switch to a browser so we can better appreciate how the admin service REST API lets us retrieve the results of our operation. As we can see, we have received some data back when requesting for the results of our operation. Up top, the URL requested is pointing to the same endpoint and collection, but the method requested is the CMPivot result method. And we're pointing that method towards the operation ID that we have previously obtained. And with that, we are able to enumerate the host GW1 and MDT1 for their operating system. Now, let's look a little bit into how we can do this with SharpSCCM. In order to avoid cluttering our PowerShell terminal with results, we're going to point our following examples to one single host. In order to do this within a SCCM, we're going to need the resource ID of such host. SharpSCCM can let us do this by using the get command with the resource tag ID option and the tag D flag pointing to the host. In this case, the GW1 host. And with that, we obtain the resource ID for such host. Now that we have the resource ID, let's switch to the invoke command with the admin tag service option. We use the tag queue to indicate a query, and the tag R with the resource ID of our target. Now we could also point this to a collection instead with a tag I flag. But in this case, let's go ahead and point it to the resource ID of the GW1 host. After some wait, we receive our results, and we have been able to enumerate the operating system for the GW1 host. You'll probably also notice that our output indicates that multiple attempts were made to retrieve the results of this operation. This is because the way CMPivot works is it will execute a PowerShell script within the target client, and only once that script has completed, those results will be available within the admin service API. So until those results are available, we will have to periodically check and continue to wait until the results are there for us. By default, with SharpSCCM, the maximum amount of attempts that we can check for this is 5, and the time wait between those attempts will be 5 seconds. We can change this configuration by using the tag D flag to indicate a delay or a wait time, in this case 15 seconds, and the tag RE flag to indicate a maximum amount of tries, in this case 3. We have received our results, and we again have been able to enumerate the operating system for the GW1 host. This time we got the results back on the first attempt, and that is because we extended the wait period to 15 seconds. These amounts will vary within your network. Now let's try to execute a different query. Now we'll try to enumerate all the installed software on that particular client. And let's also try to retrieve our data as JSON with the tag J flag. We have received some results. We can see that the different software that is installed on this host has been presented to us. Now, this is a lot of JSON, so let's attempt the same query, but this time let's try to apply a filter to it. Let's have our filter show us only the software with a product name of Microsoft Edge in this case. We have received our results, and we have been able to enumerate software installed with the product name of Microsoft Edge on the GW1 host.
That's all for the demos. Again, if you would like to check out more resources, more examples of what you can do with the new CM Pivot feature, more examples of the research we've done and the different site takeover abuses, please head over to the GitHub, check out the tool. On the wiki, there's a ton of examples and usage. If you have any questions, please don't hesitate to reach out to us on Twitter. I'm @_mayhem and Diego is @DylomSec1. Thanks a lot.